This video is going to help you see the connection between the area model we're learning in class and how this will in the future help prepare them for when they learn the traditional algorithm. A lot of times with algorithms, what happens for students is they're trying to memorize a series of steps, and those traditional algorithms, if you really understand what you're doing, you don't need to have steps to memorize. It's just going to make sense of what the next step would be. And I'll kind of show you what I mean. So as I go through here, I'm going to show you the area model. And after I show you this area model, then I'm going to come over here and I'm going to show you the traditional method. And I'm going to show you it to you two ways. I'm going to show you my first way and how most of the time we talk about it in series of steps. And two, how we want the students to be able to think about it. So whenever they go to solve these problems, it's not memorizing steps, it just makes sense. So I'm going to show you for the area model first. What we talk about in class is that area, we multiply the two sides to figure out how much is all on the inside, because really it's just one big array. Well, the problem is I can't do 43 times 50 in my head. But what we can do is, as long as we use this full amount, as long as we use all of 43 and all of 52, we can split those up into any numbers we want. And we want to split them up into numbers that are easier for us to multiply. So the first one I'm going to do is I'm going to split 52 into 50 and 2. I'm going to put a line in between here. Now if I tried to put 43, I would quickly find I can't do 43 times 50 in my head. I could probably do 43 times 2, but 43 times 50 would be tough. So I'm going to split 43 into 40 and 3. Now this is the distributive property, which is what we want kids to know. Really what we would do is if we were to split this apart into 40 and 3, 50 and 2, what would happen is we would be distributing these amounts across. We would have to do 40 times 50, 40 times 2, 3 times 50, and 3 times 2. The area model is a great way for them to visually see the distributive property in a much more organized way. And it connects to area. So 40 times 50, let's do that first, and we would get 2,000. 3 times 50 would be 150. 40 times 2 would be 80, and 3 times 2 is 6. Now we have to find what the sum is of all of these numbers to get our actual answer. So when we add all of these up, some students like to rewrite all four numbers. I prefer personally to add across and then add up those two sums to get my final answer. So 2,080 and 156. When I add these up, I get 2,236. Now when we do the traditional area model, here's commonly how people refer to it and how people talk about it. Is they say, okay, we're going to start here in the ones place, and you'll say 2 times 3. You'll write the answer down. Then you'll say 2 times 4, 8. Then what you're going to do is, the next step is you put a 0, and you're going to do 5 times 3, 15, carry your 1, 5 times 4, 20, plus 1 more is 21. And when you add these all up, 8 plus 5, 13. You can see I got the same answer. Now here's the thing for kids that's really important, is whenever they solve this, we really want them thinking about place values in the distributive method. That way they're not getting tricked by, oh wait, when do I put my 0 and which number am I multiplying now? I'm just the distributive method. It just looks a little bit different. So I'm going to take 2 times 3, and I'm in the ones place, so of course I'll write it in the ones place. 2 times 3 is 6. Next I have 2 times 4, but really that's not 4, that's 2 times 40. And 2 times 40 is 80, so of course I'm going to write the 8 in the tens place. Now I'm going to come over here, I'm going to say 50 times 3. And 50 times 3 is 150. 50 times 40 is 2,000. Now when I add these up, 6, 3, 1, 2, and see I got the same answer again. But whenever we go through and we say carry the 1, 5 times 4, that's not really what it is. And as students get into more advanced math, if all they have is just a series of steps memorized, it's one of those things, if you don't use it, you lose it. And we want it to be so ingrained in their minds so they understand what it is that they're doing, that this makes a lot of sense. It's not steps, it's just what you do next, because that makes sense in terms of as we're working with place values. So I hope this video was helpful so you could kind of see how this will eventually help our students be ready to use our more efficient traditional algorithm.